Hello, everybody. Here we have a rational expression, 2x squared minus 3x minus 2 over or divided by x squared minus 5x plus 6. Don't forget that a fraction is really the same as a division symbol. A division symbol is sort of a fill-in-the-blank fraction if you make it big and cartoony like that. So something divided by something. A fraction bar and division symbol in the calculator are the same thing. Now we are asked to simplify the rational expression and then state restrictions, and we're going to build on that one step further, and we're going to imagine if this were y equals, and if we're getting graphed on a plane, and we were talking about domain, which is describing x values, and range, which describes y values as they relate to a graph, where would the discontinuities in the domain be? And what type of discontinuity would they be? So let's see. If we wanted to get this started, similar to the last example, we have a numerator and denominator in the form of a quadratic trinomial. Quadratic trinomials are in the standard form of ax squared plus bx plus c. Now, if a equals 1, we could take a shortcut when factoring, and that makes life pretty easy. However, in this example, a equals 2, we can't take a shortcut. Some people might know how to do some of this in their head. I will do it the longer way. So for anyone who chose not to review how to factor because they were being lazy, it's your lucky day, because I'm going to go over very quickly the method again. So we're going to factor top and bottom. When we simplify, we say to ourselves, factor first. There's our alliteration. And then simplify second. Factor first and simplify second. Let's get moving. So that arrow points to nothing now because I ran out of room. White out. Okay. 2x squared minus 3x minus 2. We're going to do the AC method, which will be 2 times negative 2, which is negative 4. Factors, pairs of factors that make negative 4 when you multiply them. First, I ignore the negative. I just start with 1 and 4. 2 and 2, not so bad. Pretty small number. It's a little annoying if it were like a 48. Oh my gosh, a lot of numbers, right? Bottom of the list, B for bottom, B for but what? But not only do they need to multiply to give me negative 4, but they need to add to give me negative 3. That's going to be the 4 and the 1. When you multiply two numbers and get a negative, are they both negative? Is one negative or neither negative? If you multiply two numbers to get a negative answer, should only one of those numbers be negative? Both of them be negative? None of them be negative? What situation are we looking for here? Exactly, one of them. Good. Now, if we have two numbers and we're adding them, and they add to give us also a negative, should they both be negative? Maybe, but we just said one of them is, okay? Now, which one? If the answer is negative when you add them, should the smaller one be negative or should the bigger one be negative?
The big one should be negative.
Right, you have more negative ingredient. It makes for a negative recipe, okay? So we're going to have a positive one. We're going to have a negative 4. What will that look like in the factoring? Remember, we have first, we have a middle, and a last. First times first, last times last. Middle, FML. We're going to split that middle up. These are arrows. We're going to split that middle up to make the oi to spell foil. And that'll be our quad for the quadratic. And then we're going to factor by grouping. The oi is the plus 1 and the minus 4, but they get an x. Plus 1 and minus 4. So what do we get? 2x squared plus 1x minus 4x minus 2. If you struggled with the factoring, make sure you're paying attention. If you got it, but it took you a long time, make sure you are taking it all in, okay? So from here, I'm just dealing with the numerator, underline, greatest common factor. The biggest thing these have in common is an x. They don't both have a 2. They both don't have a square, just an x to spare. Biggest thing these two have in common, well, we always use the leading sign, negative, and 2. They do not both have a 4. They do not both have an x. That is still division. So we divide it out, but we also multiply out front by it, or you could think of it as pulling it out front. Then you reduce pretzel style. Reduce that, reduce that. In order to reduce rational expressions like this one that have plus and minus signs in them, if you want to cross stuff out from top and bottom, you got to do what we do with the pretzel. You have to have a monomial on bottom, one term, no plus or minus signs. And then whatever it is in bottom that you want to reduce out, everyone on top has to have it as well. Reduce that way, like a pretzel. And then the same idea right here. Watch if you draw the little ovals for the pretzel that you really grab any plus or minus signs in front as well. This becomes 2x plus 1. Then that minus 2 is out front. Reduce that. 2x plus 1. They should match. If they do, give yourself a high five. If not, either you messed up or it's not factorable. What's the P word for something that's not factorable? What's the P word for something? Prime. Yep. So if it were not factorable, it might be prime. So out front over here, we got that greatest common factor. I know it's poor grammar, poor English. It's, not what I'm trying to go for right now. That gets pulled out front. We reduced it from everybody, kind of like the underline, put 2x plus 1 under, pretzel it, right? What's left? X minus 2. So this right there is my factored. What's the top of a fraction called?
Numerator.
Thank you. That's my factored numerator. Now the denominator should be a little easier, like I said, because the a is 1. 1 times 6 is 6. Now, SAT likes these types of examples. I gave them a name. They don't really have a name. This is a me thing, okay? I call this the one away quadratic. One away. One away because BC. B is 1 away from C. 5 and 6. See what I mean? 4 and 3, 7 and 8. And why do those mess people up? Because people think by mistake, they're like, okay, so I need 2 numbers that they mix it up, and they might say to themselves, multiply to give me 5 and add to give me 6. And then they accidentally use 5 and 1 instead of what they're supposed to use. So they know what they're doing over at College Board. They're not messing around. So if you want your own little insurance policy, that you're going to not get tricked by those College Board questions, okay? You can kind of take all these tips that I give you and put them in your back of your brain. You can't put them in your pocket. You can't bring them with you, but your little memory bank of insurance policy to make sure that you don't get tripped up. So they like the one away. You got to remember AM, like we have math class, 8 a.m. in the morning, AM, add to that, multiply to that. So don't get tricked. All right. So what multiplies to give us 6? Now this one is a double trick. It's a super doozy. What multiplies? So we said A, C. I'm just going to do it a little on the side here. That's 1 times 6 is 6. What multiplies to give us 6? Well, 1 and 6, 2 and 3. What do you notice about these numbers and the number 5? 1 and 6, 2 and 3. Why is this one a double doozy? Go ahead, Paige.
Because they both add to 5.
Yep, there's another B word right there. They
Or add or
both
subtract to 5.
Right. They both make a 5. Well, we add with negatives, same idea, right? They both can make 5. Positive, but we want negative 5. So it could be a negative 6 with a positive 1, or it could be a negative 2 and a negative 5. But, another B word, but again, but it has to multiply to be positive 6. So you have to be very careful that you pick the right one. Do not just pick the first one you see. Which pair are you going to pick? One and 6 or 2 and 3?
3.
The 2 and the 3, negative 2 and negative 3. Good. So my denominator, this right here, I'm going to just draw a line down over here at the bottom. And I'm going to put my factor denominator. We could take the shortcut because A is 1. -2 and -3. So what's going down here? X minus 2 and X minus 3. So bam, the factoring is done. Can some of you do that much faster? Absolutely. You can do it faster. I reviewed it for everybody because I want you guys all to be able to do it and do well on anything like this in the future. Now, is there anything, we factored first, is there anything that we can simplify second? Simplify? Hello? What can we simplify?
X minus 2.
Thank you. The X minus 2's gone and gone. So simplified answer, simplified, fully simplified. So simplified is simplified 2x plus 1 over x minus 3. There we go. Now the restrictions. Now it's time for the restrictions. What are my restrictions and what type of restrictions do I have? X cannot equal.
X cannot equal negative 0.5.
Where are you getting 0.5, negative 0.5? We can't divide by 0. That means the denominator can't be 0.
Right. Sorry. X cannot be positive 3.
Right. X cannot be 3. What else? Remember, even anything that you reduced, got to look at that.
X cannot be positive 2.
Good. 2 restrictions. Which one's removable and which one's non-removable?
The x2 is removable. And
Good.
And the 3 is not removable.
Good. So I'm just going to abbreviate it a bit, but we got removable, REM, and non-removable, non-REM. And that is it. So the non-removable, I'm going to just go with pink because you see it in your simplified answer. The removable, blue, purple, whatever, you know, I just colored over there. So the removable, actually I'll do purple because that's what I crossed it out in. I don't know how different those look on camera. Oh, a little. Okay. And those are your restrictions. And that is it. Do we have any questions on this example? I think you should have the hang of it a bit, right? And we're going to move on to the next thing. Thumbs up if you get it. Thumbs down if you don't.